Alright, welcome back to Chem with Go. Today we're going to actually ask a question. I'm going to challenge sort of the what you've learned, the conventional sort of information that you've learned in the past, in all your past science classes. And I want you guys to think about electrostatic forces, positive and negative charged particles, even the ones that are neutral, and the inside of an atom, the nuclei of atoms, and what's wrong with the explanation for electrostatic forces and the structure of the nucleus of an atom. Right. Fundamentally, we know that like charges, repel each other, and opposite charges attract each other. So these two positively charged particles will move away from each other, and these two particles right here will move towards each other. Again, the rule is opposites attract. Now, we know that the structure of the atom happens to have, a nucleus, a central sort of location where all the protons and neutrons would be, and then a region of space around the nuclei, like this, for example, and these are sort of where all these electrons, and I'll just kind of put dots all over the place, where those electrons are kind of whizzing around at the speed of light. We don't really know where they're at. But we know that they occupy certain regions of space. So we'll talk about the difference between orbits and orbitals later. But let's actually challenge the structure a little bit, And I want you guys to come back into the lecture and tell me what is holding the nucleus together, because it actually doesn't make any sense, Now, from your previous science courses, you know that the nuclei, the nucleus of an atom contains the protons and neutrons, and then the electrons are just kind of on the outside. Now think about that really quick. If we have helium, and here's the isotope notation for helium, it happens to have two protons in the middle, two protons and two neutrons like this in the nucleus, and then it'll have two electrons on the outside somewhere around there. Now think about that really quick. If we know that opposites attract from conventional wisdom, why is it that inside the nucleus of any atom, for that matter, that the protons are actually held in close proximity to each other? Shouldn't these be actually repelling each other? Right here, from what we know about electrostatic forces. So there's got to be something to hold these particles together in such close proximity to each other. Now, what would that be? And you might consider the neutrons in this drawing right here, but the neutrons don't have any charge. So there's got to be some kind of invisible force that's holding these protons together inside the nucleus of an atom without them flying apart. And we know that the structure of the atom from Rutherford's experiment, the gold foil experiment, that all the positive particles in an atom are present inside the atom in the center somewhere. And they're pretty much concentrated right there in the middle. But what's holding them together if we know that positive particles, again, in close proximity to each other, will repel? Now, think about that, and you can do your research on the internet and try to find out the answer to this, Because this sort of challenges everything that you've learned so far about atoms. But you probably never considered what, this fundamentally wrong sort of explanation of what the structure of the atom is going to be. So, again, your homework assignment would be to take a look at this, try to find the answer on what holds the nucleus together, especially since protons are arranged in such a way that they're so close to each other, and they should fly apart. And if they fly apart, then atoms won't have the structures that they have currently. Right, and then I'll see you in the lecture.